Hi, it's Jeff again. So now that we've seen how to do basic CRUD operations in the shell, it's time to look at the Java driver for MongoDB and how to do the analogous operations in Java. So the first thing we want to do is pull in the Java driver to our project. So I'm going to go to the pom.xml that we saw from week 1 and just uncomment this dependency on the driver. And you can see now it populates external libraries. And these are the most interesting ones here. And as I said before, IntelliJ will automatically import the libraries that I put dependencies on in the POM. So the group ID is org MongoDB, and the artifact is MongoDB driver. And the version, I'm using 3.0.0-beta 3 because that's the latest 3.0 driver version that was available when I made this recording. But by the time you'll be watching this, it's likely that you'll be able to use 3.0.0 or at least 3.0.rc1. Check the lecture notes to see what version of the driver you should be using. So now that I have my dependency, I'm going to create a simple console application. And I'll create a main method. So with the Java driver, the entry point into MongoDB is a class called MongoClient. So the first thing I'm going to do is create an instance of MongoClient. Now there's a noargs constructor for MongoClient that, like the shell, defaults to connecting to localhost and port 27017. But I can change that using a number of different constructors. So I can be explicit about the server that I'm connecting to, as well as the port. Or I can use a class called server address, which is similar, which also takes a server name and optionally a port. And as you'll see later, when you're connecting to MongoDB clusters, sometimes you have to pass in a list of server addresses, like to represent all the members of a replica set or a series of shard routers of MongoS servers. So I can do that as well. And finally, I can use a connection string. So you can also use MongoClient URI and pass it a connection string like this. And again, you can pass in the port. There's also, with MongoClient, a number of options that you can provide. And the way you do it is through a class called MongoClientOptions. So I can create an instance of that. And because MongoClientOptions is immutable, we provide a convenient builder class called MongoClientOptions.builder, which you can use to set your options. So if you don't want to change them at all, you don't have to specify MongoClientOptions. But if you do, you'll say builder to get an instance of the builder. Then when you're done configuring it, you say build, which returns your immutable MongoClient options, which you can pass in to the MongoClient constructor like this. And as I said, MongoClient options has a number of options that you can set. None of them are required, and I'm not going to get into them here. But if you're curious as you go into deployment, you'll definitely want to take a look at options to see which ones you might want to set. Will show you one example. So a common one to override is connections per host. The default is a pool of 100 connections, but you can make that smaller or bigger as your application needs. So MongoClient, what is it actually? It's a heavyweight object in that it represents a pool of sockets or connections to all the servers that you're connecting to. In the case of a standalone, that'll be a single server. And if your connections per host is, say, 100, which is the default, this MongoClient behind it will be a pool of, at most, 100 connections. So that's a heavyweight object. So you want to make sure in your application that you're not creating MongoClients more than necessary. So it's typical to store MongoClient in a static variable for simple applications or an instance variable if you have some sort of singleton class, or you might want to configure it in an IOC container like Spring or Juice. But for the purpose of this course, we're going to be creating MongoClients in main methods because just to keep the examples short. So there's a bunch of methods on MongoClient, but the most common one for you to use is getDatabase. And you specify the name of the database like this, and the type is MongoDatabase. Now, instances of MongoDatabase, unlike MongoClient, are very lightweight. All they have in them is the few configuration properties and the database name. So you can create these as much as you want. You don't need to cache them. Databases are immutable, so once you create an instance of MongoDatabase, if you want to reconfigure it, you need to create a new instance. But we give you some handy ways of doing that. We'll learn about this later, what these things mean. But if you want to, say, change one of the configuration parameters of the MongoDatabase, there's a bunch of methods like with write concern, with read preference, and with codec registry. So for example, if you want to override the read preference, you could say like that. The only thing you have to be careful with when you use these configuration methods is that since MongoDB is immutable, you have to make sure you save the result of with read preference or with write concern back into an instance of MongoDB. Because since it returns a new instance, if you do something like this, with read preference will return a new instance of MongoDB, but since you're not storing it anywhere, it will be ignored. So you want to make sure you do it like this. So MongoDB has a number of methods, but the most common one you'll be using is the getCollection method. And like database, you have to specify your collection name. And now I have an instance of Mongo Collection. Now, Mongo Collection is the gateway to all the CRUD operations. So just like in the shell, you would say, after saying use test or use some other database, you'd say db.test. In MongoDB.JavaDriver, you say client.getDatabase, and from there you can say getCollection. And like MongoDB, Mongo Collection instances are lightweight and immutable, and if you want to reconfigure them, you use these with methods to create new instances of Mongo Collection with different configuration options. Now, the last thing to know about Mongo Collection is that it's actually a generic interface. So the getCollection method returns a Mongo collection of document. And we'll talk about document in a subsequent lecture, but suffice it to say that document is a way of representing BSON documents in the Java driver. So the reason why Mongo Collection is generic is because you might decide that document is not the class you want to use to represent your BSON documents. The Java driver actually ships with a number of different classes that you can use. We're not going to go into it here, but I can just show you how you do that. So if you want to use the BSON document class, which is similar to document, but is a type-safe map, you can do it like this. And now I have a Mongo collection of BSON documents instead of simple document classes. So in this lecture, I showed you how to create an instance of Mongo Client and configure it with Mongo Client options, how to get a Mongo database from your client, and how to get a Mongo collection from your database. And in subsequent lectures, we'll talk more about the document class and then go into the CRUD operations on Mongo collection.